I'm Angie Kellen, and this is Shot Talk with Aki Fujimura. Aki is the CEO of D2S, and D2S is the managing company sponsor of the eBeam initiative. Hello, Aki.
Hey, Angie.
Well, we just recently wrapped up the SPIE Photomask Technology and EUV Lithography Conference, which of course were for the first time ever co-located in Monterey. And then of course the eBeam initiative had announced its annual member survey events at an event there as well. So we have a lot to talk about. Let's start talking about the surveys. You had some interesting content that you wanted to share about the surveys, and I'm going to let you start off with that.
Okay. Yeah. So yeah, we had I would say 3 or 4 major takeaways from the surveys that we did, and EUV was by far and above the biggest thing. EUV being perceived to be ready for production use in the coming years, and I thought there was a clear indication of that from multiple angles. That mask data preparation is a big part of the increasing turnaround time problem in the mask shop, and that was clearly indicated by the survey. I thought that was interesting. And it was probably due to the need to do mask process correction, or MPC, an OPC-like process for mask making, as accurate as eBeam is as an instrument for writing masks, and now features that you need to write are small enough that you need to correct for them, and needing to do that clearly starting at 10 nanometer node, but now required at 7 nanometer node, I think is what was indicated by the survey results. So that was interesting, and MPC is an important topic. IoT, or inverse lithography technology, which is kind of a more advanced version of OPC, more complex version of OPC, perhaps even producing curvilinear shapes, and that becoming more normal in terms of at least partial use on any given reticle. There might be parts of it that are IoT, then that's what the survey indicated. So that was really interesting. Of course, that increases the need for mask process correction that I talked about earlier, and it also increases the data preparation time. So all of that is consistent together. Multibeam perception was also very prominent. There is no doubt in people's minds that multibeam is imminent for production use, but there's a little bit of like a 10-month delay that was projected in what people thought the first use of high-volume manufacturing multibeam is going to be. But I think that's just kind of a last minute, last 5% takes 95% of the time kind of a thing. And I actually fully expect that production use is going to be much more prominently indicated by the perception survey in the next year's survey. So I thought it was very illuminating. Please go take a look at the presentations at the ebeam.org website, and please use it in your presentations wherever you can, maybe for business case justification, or maybe in comparison to what's happening with the rest of the world, or maybe to indicate what everybody else is thinking is going to happen in the future, or maybe even to say, hey, this EUV program needs to be funded today, whatever. Please use it either in public or private forums.
So let's talk about your key takeaways for the conference itself.
Yeah, so the conference itself, for the first time, it was a combination of the EUV lithography conference and the mask conference, and the organizers had the vision to combine it together. I thought it was great, particularly this year, where the survey is clearly indicating that EUV is just about ready to happen, and the entire ecostructure better get ready for EUV lithography. In order for EUV lithography to take advantage of it, EUV mask has to get ready, and so on. And the particular benefit of having the conferences together was, from my perspective, being on the mask side, it's always great to get a little more in-depth insight into what the customer's problems are, even if it's not directly related to your own technology, because you get a little more insight into what you need to do for them to be helpful to them. So I think this opinion was shared by all, and it was a fantastic timing to be able to get that insight from the EUV lithography issues, and also focus on the common point, which is the EUV mask set of problems. And there was a interesting kind of extension of that in a panel discussion that happened on Wednesday afternoon that was run by Emily Gallagher, one of the co-chairs of the conference this year and next. And I thought it was great. And the basic idea of it is actinic inspection, which is about inspecting EUV masks using EUV light, and is not going to be ready anytime soon, or in the next 2 to 3 years. So, but EUV is getting ready within that time frame. So what are we going to do while we're waiting for that? So I thought that was a very interesting topic, and an interesting set of discussions.
Well, now, Tom Four of Global Foundries had given a talk on what's different for EUV masks. And for those of you that would like to know, he is part of our Tech Talk feature, our segment here on this edition of the Fine Line Video Journal. So, Aki, what did you find interesting about his talk?
Yeah, Tom's talk was great. There was, of course, an entire session about EUV masks, but what Tom did uniquely was to consolidate and summarize all of the different things about EUV masks that 193i mask processing hadn't had to deal with before. And what I personally found as a takeaway, from that presentation, was what he said about IoT on EUV. And he said that when we need SRAFs on EUV, these small assist features on EUV, it's probably not going to be 7 nanometer, it's probably 5 nanometer, and it'll definitely be required eventually. And when it's required, the sizes on the mask in mask dimensions are about 30 nanometer. And 30 nanometer features are not something that can be printed today with ordinary 193i mask resists. So clearly resist is going to have to change, and he said maybe 100 microcoulombs per centimeter square below, a little bit below that maybe. So it's definitely much more dose is required to expose that. eBeam initiative event had a panel session to discuss some of these things, and in that panel discussion it came out that probably multi-beam mask writing is going to be required by the time EUV is really taking advantage of all that EUV can do. And initial EUV adoption is not doing quite that. So initial EUV adoption is probably going to happen. EUV is projecting, but the rest of the infrastructure is kind of still the 193i infrastructure to ease its way in. The industry eases its way in. But eventually, of course, we need to be able to take advantage of all that EUV can do. And when that happens, the infrastructure has to be improved. And in that situation, the mask writing is going to be much more difficult, and multi-beam is going to be required.
Now, Jed Rankin of Global Foundries is a co-author of that as well. And so you know he's part of our Perspectives piece too as well in this edition of the Fine Line Video Journal. So I know you you know Jed.
We've known each other for a little while here, and he's a great guy. He has 150 patents to his name in very broad areas in semiconductor manufacturing, and so his broad and deep knowledge of the industry, I think, is particularly great for he being named to be a co-chair of the BACUS, as we call it, the SPIE Photolithography Conference. Is very, very good. I'm extremely happy about that. I really look forward to helping Emily and Jed in whatever little way that I can in the coming year.
Now let's switch gears, Aki, and put on your D2S hat.
Okay.
Now Samsung had provided in the news an update on EUV. And how is it that D2S supports EUV?
Yeah, on Monday of the conference, Samsung announced that at the 11 nanometer logic node, they're going to be deploying EUV for production use. So that was it's very consistent with perception survey and everything else we heard. And the entire industry has to get ready for EUV, and D2S is ready. And the biggest change in simulation-based processing of mask is that EUV has a big mid-range effect, which actually exists on 193i masks also, but it's very little. In EUV, it's so prominent that if you don't correct for it, you won't have a viable mask. And we correct for it. And Ryan Perlman talked about that at the conference and in the video also. And we call it True Model, which is the model from D2S. And True Model incorporates the EUV effect along with all of the other effects together. There are kind of two different ways in which it can be deployed. One is the set of geometric corrections that True Model can do for any writing method. And then there is also a PLDC capability that's inherently a part of the New Flare NBM1000 mask writing system, Multibeam mask writing system that incorporates True Model so that it is ready for EUV correction as well.
Now, Aki, in the past, we talked about your focus on GPU acceleration. How's that going for D2S?
Yeah, great. We have a couple of new programs that I'm not really ready to talk about today, but next year. And we have several things that we've been working on for the last 3-4 years that are finally seeing the fruits of their labor. So the biggest one is the PLDC capability that is a part of the New Flare NBM1000 multi-beam writing system, the next generation multi-beam writing system. And Matsumoto-san of New Flare talked about that at the session. In addition, Nakayamada-san of New Flare talked about some of this in the panel session during our Monday event too. And they were showing a picture of a SEM photograph of a mask that was written using PLDC. So it's really great to see that. What PLDC is, it's a pixel level dose correction, which means being able to do pixel-based dose manipulation to make linearity correction and also to improve the manufacturing reliability of all of the masks that are produced, that are written using NBM1000, and doing that by dose manipulation during inline real-time processing, which means as the mask is being written, the the correction is happening. So there is no separate time required ahead of mask preparation to do data preparation. And because data preparation is known from the perception and the mask maker survey to be a problem for the leading edge nodes, and we think that this would be a good contribution to the mask making community.
Well, Aki, I want to thank you for your time once again and sharing your insights with us. And we hope you'll join us for future editions of the Fine Line Video Journal.